not all classes are comparable, right? Fine. Not all class will have a natural ordering. Okay, fine. So some classes, even if whether they have a natural ordering or not, maybe account, someone says, okay, oh, we don't keep account number comparison as natural ordering. We don't want to put implements comparable. Yet, we would like to compare two account objects based on various different criteria, right? We compare account based on name, based on balances. Okay, fine. So it could be with any class. So there is a separate, fine, to define any kind of ordering. Fine. So this is what is the class which is used for ordering. Fine, defining the ordering for any type. So interface, right? So now this is in the java.util package. Okay, this is the interface called comparator. Okay, it's used for defining the comparison logic, right, for any type. And when I'm referring type here, I'm referring to the non-primitive types. So this is you who will now decide how the comparison is to be done for a given type T. This is also a generic interface. So this is in, so this is, I should rather put it as, okay, so we have this as java.util.comparator of some type T. This is the interface. Okay, this interface, let's look at this interface, the method in this interface. Okay, here again we have an abstract method. Okay, the abstract method here is public method returns int. Name of the method is compare. Fine. And parameter is t. This is the abstract method of, okay, comparator. See, if something is comparable, then it will be compared with some other object, right? It is comparable, and therefore I'll be comparing the object of that type with the other object. Whereas what is comparator? Give it two objects and it will tell you which is greater, which is less. That object of comparator is not to be compared with something. He is the one who has the logic of comparing two items. Okay, fine. So here, yeah, we have this, we understand, right? That, okay, returns less than 0 means T1 is less than T2. Okay. Similarly, greater than 0 to mean T1 is greater than T2. Okay. Equal to 0, T1 and T2 are equal. Fine, clear on this? Fine, the difference between comparable and comparator. Okay. Fine, the comparable and the comparator, two types are there. Comparable, oh, they have a natural ordering, then only will be putting comparable. And in case of comparable, the logic is about comparing with one more item. When it is this to be compared with someone. Whereas in comparator, you have to create the object of comparator, okay, and give it two objects. It will tell you which is greater, which is less. Fine. So it's like, if it is natural order, we'll say AC1 dot compare to AC2. Okay. So this is according to the natural order. But you may have some other ordering, right? So for example, there is a comparator which compares by name. Okay. So you can say name comparator. Okay. So someone would have to create the object of comparator of account. Yes, it's for comparing two account objects. Okay. In that case, yes, we have a name comparator. Let's say this is okay. I'll put it this way. Comparator of account. Okay. Name comparator equal to, yeah, we'll be having some way of creating it. But then the usage would be, okay, name comparator dot compare AC1 comma AC2. Okay, this is integer value, this is also integer value, right? But this is according to natural order, this is according to name order. Less than means, oh, AC1 comes before AC2. These are both integer. This is also integer and this is also integer. When here on AC1 is being compared, here name comparator is giving us the comparison. It's not the comparison logic in account class. It's a logic in the outside of the class. Okay, the logic is not in that same class. Natural order you'll put in that class itself. Any other ordering, okay, it will be outside the class. Okay, let's think of this one. Can we think how it can be done? This interface, look at that interface, comparator interface. What does it have? It has only one abstract method, right? If it has one abstract method, then it is a functional interface. So can we think of the logic here now? What are the inputs? It is a comparator of account. What are the inputs? Two account objects, AC1 comma AC2. Okay. We have, the name is of type string and string is implementing comparable. So string has a natural ordering. And we will do fine, we can order by that only. Okay. Yeah. So yeah. What's a AC1 dot, I don't compare AC1. If I compare AC1, it will go by natural order. Yeah. Okay. I'll take this in the next line. Yeah. Now tell me. Dot. Yeah. AC1 dot get name is a string. Has a natural order. String has a natural order. Compared to AC2 dot get name. See how we use lambda expression now. Yeah. Fine. Similarly, if we want to compare by balances, we have a balance comparator. Okay, so we can create these comparators. This is fine. This is good, right? Comparator creation of a defining a when creating a comparator is easier. No, with the help of lambda expression. This is a comparator which wants to compare by name, right? This wants to compare by name, and therefore extract the name and make their comparison. String is comparable. Okay, yes, we need to know that string implements comparable of string. Okay, fine. What else? Can we write a balance comparator now? Okay. It will be again a comparator of account, right? Balance comparator equal to, yeah, how do we put this? AC1 comma AC2, yeah. Yeah, how do we do this now? Yeah, you will be interested in, I think, AC1 dot get balance, because we want to compare by their balances. But then this is a primitive, need to be converted to noun. Okay, dot compare to, and as a parameter, yeah, what will you pass as a parameter? And so this is the one which will compare by balance. So that's my balance based comparator. Okay, so creating comparator for a type. Comparator because not according to natural ordering. Fine, we don't want, fine, because we have some comparison logic. Fine, you may have different comparison logic. It's up to you. You write your implementation. This lambda expression, you define what it is. You can have some other comparator also, right? Where it is comparing initially by balance. If balance is equal, and then I want to have comparison based on name. Oh, then change this, right? It's not just a balance comparator, balance plus name comparator. You can have some other thing which is just based on balance and then on name. But comparators can be written. Yeah. Okay. So if we can write comparators, let's see where these comparators are used. Oh, we started. What is our problem today? We want to sort an array of account, right? And oh, we don't remember those various algorithms which are there, which one to choose. So we have some ready-made methods. Okay, there are ready-made methods in the available to us. Okay, oh, it's related to array. Now, related to array, right? Various methods, various utility method related to the array, sorting, and there are so many other things which you like related to an array. All such things will be available. So are available in the class java.util.arrays. So there is a class called arrays, right? And it is full of static methods. Okay. Has a lot of static methods. Okay. So one of them, we are interested in sorting currently. Okay. So I'll tell you what are the methods here. Okay. So we have two methods, and once I give the method signatures, then you should be able to realize how the two will be used. Okay. So one of the methods is like this: public method returns void, name of the method. Oh, these are all static methods, so you don't have to create object of the class arrays. Arrays class has only static methods. Okay, fine. So there's no need to create an object of the arrays class. We'll just say arrays dot sort here. Fine. Arrays dot method name. And what is the parameter it takes? It says, okay, you give me any object array, and I'll be able to sort. It's not taking any other parameters, just taking object array. Then what is it doing? In that object, it's looking for a natural order. It thinks that the array which you have given has a natural order. It thinks it's comparable, and the logic of sort which has been developed there is thinking about using the compare to method. So internally, this is doing a casting to a comparable and calling the compare to method. There's no other logic we have provided. We are saying, oh, this is an object array. If it is not a comparable type, what will happen? It's doing a casting, right? It's saying cast to comparable. If this class which you are, the array has objects of a class which is not comparable, what will happen? So an error. Then it will give an error, oh, class cast exception. This cannot be, this casting is wrong. It's not comparable. Okay, so this one, because we are not providing any other logic, and therefore it gives a error in case it is not comparable. So this is meant only for those items which are comparable. Okay, now look at the other static method here. Okay, void sort method, but takes as, oh, this one is a, this method is a generic method. Says, okay, it is for some type T. Parameter, array should be of the same type. Fine, array is of type T. That's my array. And a second parameter. So you want to sort an array of T, give me the logic. Where is the logic defined? It should be a comparator of. Okay, let's put T currently. Okay, so that's the other comparator. Fine. So this is a method which is available in the arrays class. So you can use arrays dot sort to sort an array of any type, but you should be passing a comparator for that type. Okay, I have an array of current account. I have an array of current account, but I have a comparator which is for account. I have defined a comparison logic for comparing two account objects. My T here is current account. T here is current account because I am passing an array of current account. Comparator should be of current account, but I don't have comparator of current account. I have a comparator for account. Can I use it here? See, if this is the way method signature is given, then no. Okay. Okay. First, maybe before going into that, let me first put this, how you might use this one. So for example, so if you have an account array, okay, accounts equal to, and let's not worry about how it has been initialized and other thing. So you got an account array, and suppose we have an account array and I want them to be sorted by name. What should I be doing? Arrays dot sort. What's the parameter? First parameter is the array. What's the second parameter? Name comparator. Put a balance comparator, they'll get sorted by balances. Okay, fine. But one thing, my question was, if instead of account array, I had a current account array. Still, account array, this name comparator should be allowed here. That won't be allowed if this is the way method signature is given. Okay, now this is related to generic. Okay, instead of T, and there is a syntax which is involved here, we say anything which is a super type of T, a comparator of anything which is a super type of T. Your comparator need not be of the type T only, but it can be of type above T, super, fine, over T, fine, not below T. It can be T or above T, super type of T. So this we call as a wildcard. Question mark means wildcard, but it is a bounded wildcard with lower bound. Okay, so question mark super T, fine. Okay. With a lower bound. And so question mark super T, which we have used in that just above line, is nothing but we call it as bounded wildcard with lower bound. So when we have a generic parameter, yes, you could be mentioning a, so this is not where you are defining. Yesterday what we had seen was, when we looked at generics, a bounded type parameter. This is not about a bounded type parameter. Okay, this is not about a bounded type parameter. Okay, fine. So someone could even be writing, so it's bounded type parameter was when you are defining a generic type, when you are declaring a type parameter. Here we are not declaring a type parameter, we are invoking the comparator, which is a generic type. So see one thing here. Okay, even in the earlier case, like suppose, yeah, I'll just make it again T here. Yeah. So what is T here? What is T here? Because comparator is a generic interface, we have to specify some type. Okay, fine. This method is a generic method and has its own type called T. Okay, let me change this then. Okay, some type S, let's say. Okay, so this has nothing to do with the comparator's type parameter T. We only know that comparator requires some type to be mentioned. Okay, so how do I pass this? I can say, oh, it can be of type string also. Someone says, okay. See, when I'm invoking I'm invoking. Okay, I'm invoking. I'm using a type, which is a generic type. So I'm using comparator and I'm not defining comparator. When we define comparator, we give, if required, we may give a bound. Okay, when defining a comparator. Whereas here, it's not comparator getting defined, but rather being used. So when we use, we have to give some type. So you could have given string also. So that is a valid, okay, this is a valid way of invoking, using the comparator. I could have said S because it's a type parameter available for me. This is also a type. S becomes a type for me. Fine. For this method, S is a valid type, whose type will be determined when someone is invoking the method. Okay, it's related to this, right? S, yeah. So now, wherever we pass, when we want to specify a type, okay, we can also use a wildcard. For example, if I say question mark, oh, this is also a valid syntax. Syntax as it is valid. Comparator of question mark. What is comparator of question mark? We say unbounded wildcard. This is known as unbounded wildcard. That means comparator of anything would be allowed here. Okay, and we'll say comparator of question mark super S. Question mark super S. Either it is same as S, comparator of S, or you give me a comparator of any super type of S, that is also acceptable. If it was saying comparator of S, it would only be accepting comparator of whatever the type of the array is. Array is of S type. S is some type. So whatever the type S becomes, so whatever the array type, the comparator should be of that type. But by putting question mark super S, we are saying, so T is a question mark super T is a bounded wildcard with lower bound. So in case of comparator, yes, it is a good idea to have a bounded wildcard with lower bound, because this is the lowest. S is the lowest. Anything above this, so this is known as the lower bound. Okay. There is another case. Now, just as a small example, okay, and just as a small example, what we would be doing is, okay, I'll just explain. There is, I'm just giving another interface which will come across later. Okay, and just I'm just taking one method as an example here. There is some data structure called list. Okay, so I have a list of some type E, let's say some element type E. So there is a list of elements, some type E. Okay, this is an interface which is defined in Java. Okay, there is a list of E. Okay, so if it is a list of E, this has a method. Fine. This has a public method, returns boolean because it was added or not. Fine. Sometimes it may not add because, okay, for certain reason. So there is a method called add. So if it's a list for the type element type E, add method should take parameter of type E only. Okay, fine. Whereas there is another one, okay, returns boolean, method name is add all, but it takes another list as a parameter. Okay, it takes another list as a parameter, but if I use list is a generic, and therefore I must define Fine. Yeah. And specify in terms of this is a list of account, right? There is a list of account in which I want to add another list. Can I add just any list? No. I must specify what type of list it is. I have a list of account. Can I use it and add all the elements into this list? They are matching types. So someone says, okay, let's add list of E, right? So this is the other list to be used as a parameter. Right? This looks okay. Right? But what about if there is a current account, a list of current account? This is a list of account in which can I not add a list of current account? I can merge elements from a list of current account. I can't be merging elements. If it's a list of current account, I can't do the other way around. I can have subtypes of this. A list which is for a subtype of E. And therefore, we have another one. Okay. Right. Right. This list, okay, sorry. Question mark extends E is nothing but wildcard with upper bound. E becomes the upper bound for it. Okay. So we have bounded wildcard, fine, with upper bound. Bounded wildcard with upper bound. Earlier we had bounded wildcard with lower bound. Right. See, we'll keep on using this again and again. Okay, these kind of things. These are the things which will be, when we look at the data structures, then Java util package has a lot of data structures. These things, you will have to keep on using them. When arrays is the first thing we are starting with, okay, arrays, yes, we would like to use sorting of array. We start with the sorting of array. Okay, fine. Sort related comparison, yeah, sort involves comparison. Where do we have the comparison operator? We don't have, and therefore we have these interfaces, comparable and then the comparator. Comparator is more generic. Any comparison logic can be given for any kind of item. Rectangles, they don't have a natural order, but yes, you may have your own. I have this one to compare by length, this one will compare by width, this one will compare by area, another one compares by perimeter. So you can have any kind of a comparison logic and say, okay, sort them, and this is where I have given the logic for comparison. You have to specify the logic of comparison. Comparator requires that. Clear? So sort method available in the arrays class for sorting any kind of array. Okay, yeah. So any questions are there still? Yeah. Right. See, when we look at the list interface, we'll again look at this. Right? That time again we'll come across this. Okay. Right? I just showed you because fine. Okay. So if there is a generic class, right? If there is a generic class, how do we invoke? How do we declare variables of that type? Okay. So yesterday I think we said, oh, we had a generic class. If you recollect, we said, oh, we have a generic. So yeah, I'll just repeat that again. We had a generic class having its type parameter tp1, comma tp2, and it's just an example with only two. Okay, if this is what has been defined within this class, or rather from this point onwards, I have two more data types available, tp1 and tp2, which are not fixed. It depends on the user of this class. Okay, the user of class will declare variables. So user of the class says, okay, we have a variable of type generic class. Let's call, oh, so when we say generic class, we'll have to give two types. So one option is to say string, comma, yeah, integer. Okay, so this was one, string, comma, integer, and that is a variable called gc1. Okay, fine. Someone can say generic class of string, comma, question mark, extends number. Okay, fine. This is, what are we using now? Bounded wildcard. With which kind of bound? With upper bound. Upper bound is number. Anything, number is the uppermost thing. Number or any subtype of number. Clear? Clear? This is difference, right? Whereas this is a different thing. Someone was saying, oh, let's have TP2 extends number. Oh, then there's no question of saying question mark extends number here. Okay, but someone could still be saying question mark extends, and I could be saying question mark extends comparable. I have used comparable. I must specify. Comparable of what? Comparable of, yeah. What should it be? Someone says, okay, comparable of number. See, when we use any type, if it's a generic type, always think of this. Okay, and this is just as an example, right? But yeah, here question mark, because this is already bounded, right? Fine, and therefore no, it's already a number. Then this won't make a meaning. Though this is also correct, it's not incorrect, but this doesn't make a meaning. It's already bounded for number. I might like to say, okay, it must be comparable. So you can add question mark extends comparable. But whenever you use any type, right? If it's generic type, even if you are invoking it, yes, you'll have to specify a type there. Okay. And so bounded wildcard while invoking a generic type, okay, or a generic method. That's what you can use. Okay. Now, yeah, what we could now be doing is, okay, we can update the account class to implement comparable. Okay, exercise. Okay. Okay, that's one thing. Okay, and then update the test account class. Okay, update the test account class where we compare, where we create an array of account. Okay, fine. And array of account, get the account, get the array sorted by account number by natural ordering. And so by natural ordering, that's one. Or you can have it sorted by also by name, by balance. And I think those two logic anyway we have written. Also you can do by name, but case insensitive. And for name being case insensitive, fine. You can try writing logic, but there's something ready-made available. I can tell you what it is. There is the class called string, because the name is of type string. In the string class, there is a declaration which says public static final, and it says this is a comparator of string. So we have a comparator of string by the name case underscore insensitive. So this is something which you can use. So as a comparator, there's a comparator for string comparison. We understand what will happen in string comparison. Uppercase is less than the lowercase. Digits first, then uppercase, then lowercase, right? But uppercase, lowercase, you want a comparison which is ignoring the case. Then you can use string dot. It's a fine. It's a static variable in the string class. What is the variable name? Case insensitive order. What's the type? Comparator of string. So if you want to compare strings, based on strings, yes, you can use this case insensitive order. But the case insensitive order, yes, that would be used for. I'll give you one more. There's a method also. So there is a method. So in this case, yes, you'll have to write your implementation of compare method. That comparator you'll have to write. So you create your own comparator. There's a method returns in. Name of the method is compare to ignore case. It takes a string as a parameter. So in the string class, there is a instance method, where it returns int. This is the int which you can use in your compare to method, compare and compare to method. And the value becomes less, greater, or equal to 0. And we know that comparison logic is there. Fine. So that's our next part, right? Exercise. And after the exercise, yes, the next thing we would like to look at the concept of sealed classes and interfaces. This is more on types that I'm going to talk about here. And it's related to the inheritance aspect, and this is related to inheritance. Fine. Remember the keywords. Fine. For this, remember the keywords: abstract and final. We know they are opposites, right? But just recollect what they are. And somewhere in between is what you will get through sealed classes and interfaces. There are many things you can do with sealed interfaces. It's related to the types. We want to have our own types in our own manner, right? Okay, fine. So we'll continue tomorrow. If you have questions, any other questions? Any questions are there?